Yeah, we're unmuted. Yes.
We are now unmuted. Yes.
Okay. All right. Welcome, everybody. Today is March 5th to the Cleanup and Risk Mitigation Subcommittee meeting. We can go ahead and get started.
I'll start with a few administrative items. This meeting has been recorded. Will be posted to the Ampersand YouTube channel. And then for profit, if you're in the room, we appreciate you coming in near the front table. If you're online, please enter your name and affiliation in the chat. Quick review of our ground rules that are in place for every meeting. Listen carefully for the guidance of your chair. Be respectful and please have good intentions. Minimize sidebar conversation in the room and chat. Up online in the room, or leave the room if you must answer the phone call. We do have a lot of people attending this online, so please direct your conversations to the owls in the middle of the room. They are the eyes and ears of our internet participants. With that, hand it over to you.
Thanks, Josh. You covered everything I was going to say. I was just going to remind everyone, even especially people on the outer edges, talk towards the owls, not to the people you're talking to, or else they won't hear you online. Not much to add. I did do a rap sheet this term today, this meeting. That's the word. It's been a long week. Just noting that the meeting minutes that usually begin the rap sheet, some of them didn't have new entries this time period, so there'll probably be double next time. Sometimes the administrative record gets a little laggy. But yeah, any other things we need to talk about before we jump into technical impracticabilities? We have presenters. Excellent.
We do have a comment from Catherine online.
Yeah, I just wanted to mention on the rap sheet, there is the new 2024 RECRA annual groundwater monitoring report that came out. It's not listed anywhere, but it's AR 33898 if anybody wants to go fishing for it.
What's that number again, please? AR
33898.
Catherine, do you know when that posted?
February 27th, and it's
okay. Yeah,
if you have to go through the what's available in the last 90 days, because it's actually listed over under the soil and groundwater side.
Yeah, so this current rap sheet only went through February 20th. So yeah, that's probably what happened there. So it'll be on the next one for sure. But thanks for bringing that up. Okay, anything else before we jump into the talk on the technical impracticability? I want to welcome Kate Klein. And I guess take the slides up and the floor is yours.
Well, thank you.
They will be up as quickly as computer allows me.
No worries. All right. Well, hello, everyone. Good afternoon. My name is Kate Klein, and I'm a physical scientist with the Soil and Groundwater Division with the Department of Energy. And I have actually been with this group for 9.5 years now, so been around for a little bit. And today I'm going to talk to you about our UP1 operable unit technical impracticability evaluation update. Big title there. So let me go to the next slide. So kind of outlining the briefing, and so I'm going to just do a kind of background on where the 200 UP1 operable unit is located, and the contaminant plumes that are in that area, especially the iodine. And I'm going to go through the history, kind of the basis for why a waiver was even looked at, our next steps, and then I'll highlight key takeaways and then any questions. And this briefing is being provided as an informational. All right, so, here is the, Hanford site, map. And in the red box right there, that is highlighting the 200 UP1 operable unit. So it's in the 200 West area. And, iodine 129 is one of the contaminants of concern. There's quite a few, but this plume, is obviously the focus of this talk today, but there are others. And, actually the next slide, if we go to it, we can kind of see the, complex, contamination we have. UP1 is kind of, you can see there's this kind of darker line on the map, and UP1's on the southern end, and so you can see tritium, nitrate, and then we have hexavalent chromium, which is the really bright blue plume to the southeast. So we have a lot going on in this operable unit, but we're going to highlight the iodine, which is the orange plume kind of right in the center. And we can go to the next slide. And so here is, this is from our groundwater annual report from last year. So this is kind of the most up-to-date plume that, map that we have. And so this is our iodine plume. Some items to note, on the eastern side, it's kind of hard to see on the screen up here. But on the presentation and stuff, you can see that there's kind of these orange kind of triangles. They're upside down triangles on the eastern side. They kind of have this kind of shape. Yeah, kind of right there where the mouse is. Those are injection wells. Those are hydraulic containment injection wells that we have right now. So that is helping prevent this plume from migrating to the east. That was part of the interim record of decision that we have for this unit. And so far it's been very successful. Iodine also travels really slowly. So it does, that also kind of helps. So we have two things going for it. It travels slow and we have those injection wells. Another item to note is where we have the highest concentration. And so that's going to be that dark kind of circle right there. And again, it's hard to see on the screen, but up close, you can kind of see these hatch marks that highest concentration portion is located directly under our ERDA facility, our environmental restoration and disposal facility. And so that kind of, as I'll highlight later, prevents kind of a challenge for this plume. Otherwise, you can kind of see on this map, we do have concentration numbers next to the well numbers. A lot of these dark black, just solid circles are monitoring wells. And so we have quite a robust monitoring system around this plume right here. So we are constantly monitoring the contamination just to make sure of, you know, what we're looking at, if there's any changes. And so it can kind of give you an idea of what the values are for this plume. They're not super high. We do have the highest in that darkest portion, but as you get towards the edges, they get closer to our cleanup level of 1 picocurie per liter. All right, I'm gonna go to the next slide. And so this kind of goes into the history. I won't read word for word, but this comes from our UP1 interim record of decision. And so when this was written, we were supposed to put hydraulic containment in place. And so that is what we have. We have those injection wells. And then and those injection wells are supposed to stay in until we kind of make a remedial decision for this plume. We also, one of the points of this is we do have stated in here that an interim or a TI waiver for this plume could be looked at if a viable technology was not found. So in 2018, PNNL completed an evaluation of remediation technologies for iodine 129 and found at this time there are no viable technologies that can effectively clean up this plume.
Can I pause you for 1 second for clarification?
Yeah.
Can you define a technical impracticability waiver?
Yes.
Thank you.
Yep. Oh, I'm sorry about that. So a technical impracticability waiver is basically where you have remediation of the groundwater. You can't, it's very challenging or impossible at that time to achieve the cleanup level. in some way. And I mean, that's using any methods that you can think of out in that are off the shelf ready or whatever, that you just can't go out and easily extract it. It's not a permanent remedy, so a TI waiver does not mean that, you know, you put one in place and you walk away. That is not the intention of it. It's just stating it at this moment in time, there are challenges that you cannot extract or get down to the drinking water standard for the contaminant. And so what you do is reevaluate periodically any technologies as you go along to see if there's anything new out there that can actually be used to clean it up. Because sometimes we are a little bit ahead of technology, unfortunately.
So if I understand, it's, if the remediation's impossible, then you get a waiver from the drinking water standard. So,
Yeah, and so then, like I said, as you go along, you periodically do updates to see if there's any way that, you know, any technologies that come out that you can utilize them to clean that up. So it's not supposed to be intended for a forever thing or something that just says, hey, you don't have to do this, you get to walk away for free. That's not the intention at all. It's just saying, we're having challenges, we can't get to the drinking water standard. You know, here, you know, we're held to making sure that we're continuously looking at technologies. Also, you still have to maintain, you know, contaminant, you know, manage the contaminant conditions. So you still have to provide, you know, protect public health and safety and the environment. And so you still are doing monitoring, you still are looking at this. So you're not walking away. That's a big takeaway is it does not mean you get to walk away.
thanks for the tangent.
Yep, no problem.
Let's get, that was just a clarification. Let's let the, questions come after the rest of it.
All right, and so going back to the history, so the TI waiver was put into the interim record of decision that if we didn't find any viable technologies, that this is a possible path to look at. And so because PNNL did this study and found that there wasn't anything, there was a lot of challenges, excuse me, there just was nothing that was off the shelf ready that we could apply. We went down this path. And next slide. And so the basis that we found for, you know, going through this waiver is we have low concentrations of iodine 129 on a lot of places. They're not much above the drinking water standard. And so that does create a challenge when you're trying to extract. Because you end up pulling in a lot of clean water and it's just, you don't have a high concentration to try to get to. You also have long half-life. Iodine has, you know, I think it was a 15.5 million year half-life. I mean, it is a long time to start, you know, degrading over time. And so that does present a challenge because, you know, we don't want to wait 1.5 million or 15 million and a half years. We also have multiple iodine species. So we have iodine 129, but we also have a stable form of iodine 127. And so that kind of creates a challenge, and that's what we found with the technologies is iodine 127 like to be favored in certain treatment capacities over 129. So then it was taking those spots that 129 couldn't be, you know, taken up. And so then it created this challenge of it just wasn't efficient. You weren't getting the contaminant you wanted. And so those multiple iodine species do create a problem. And then we also have a low cleanup level. The cleanup level is 1 picoperiod per liter. So that is hard. A lot of the labs, it's a challenge to have detection limits that low when they're doing the testing the samples. And so we have found a lab that can do it. It starts getting into that error range. And so it's a little bit of a challenge to have that low of a cleanup level. We also have lack of effective technology, like I said, with that technology evaluation. And also the plume is located beneath Erdith, the highest concentration of where we would actually, you know, think about even extracting from. And we can't go and drill a well underneath Erdith. That's just not, that's not okay. We don't want to create an even bigger problem. And so that location does create a big challenge for us. Okay, next slide. So, next steps. So what we have done is we have actually drafted, the TI waiver, and we've gone through some comment resolution with EPA. But right now, this effort is on hold. We have a lot of other Central Plateau decisions that are being made right now, in various capacities. A big one being, especially with groundwater, is our ZP1 operable unit and our UP1 operable unit too. And so right now, we have just put this down, and we want to see and wait of what else is going to develop to help us see if maybe, if this is actually a decision we want to go down or not. The waiver would require a record of decision change because right now, UP1 is interim. And so, especially waiting till a final round, we would have to go through a process, to get this, decision, whatever our decision would be, to get that included. And so, and that would go out for a public comment period too. Any changes to the ROD. So there would be public involvement in that decision. So, and then, so next slide. So this is our key takeaways. So just to kind of wrap up, iodine 129 is a contaminant concern in the UP1 operable unit. The UP1 interim record of decision stated that, the use of a TI waiver, could be considered if no viable technologies were found. And so PNL's evaluation, did show that right now there's no off-the-shelf technologies. We have, as I went through the bases, we have multiple bases for the waiver. We do have a draft TI waiver that's been written, but it is currently on hold right now, until we kind of make some other Central Plateau decisions. All right. Any questions, which I know there's probably a few.
So we'll give it to you for questions. First, we go to the regulators.
Okay,
And
yeah,
then we
sorry.
go.
Yep.
I guess EPAs or are you? Yeah, okay, sure.
Hi, my name is Annie McCartney. I'm with EPA. Thank you, Kate, for giving the presentation. So just a couple of things I was gonna highlight with technical and practicability waivers. One of the key things under the circular regulations are that you cannot waive protectiveness, which Kate touched on briefly. So we evaluated the evaluation that was provided to us and had certain areas that we were looking at. One of the main things is that the plume has to be contained and stable. It cannot be, or shrinking, it cannot be a growing plume or spreading. Protectiveness, meaning that there will not be exposures from a result of a waiver during the time frame of however long that waiver stays in place or while there is no technology available. There is a defined boundary to TI waivers. They cannot be indefinite. It would not apply if we did go forward with one like across Hanford, right? It would be very specific to the plume and actually have an outline of where the waiver applied to. And it is specific to the groundwater. One of the primary concerns we had at this point in time with moving it forward was that we haven't fully characterized the source operable units yet. And even though we have a lot of process knowledge and we know more or less, what the past contributors to this plume were and everything, there really is a requirement for. And so it didn't make sense at this time. There's a lot of work to be done, like in 200 WA1, the west area. Source sites where we have soil contamination that still really needs to be characterized and ideally addressed before a waiver could be authorized for the groundwater. So the timing just kind of wasn't right, even though we went through a lot of the effort and worked out a lot of the details that would go behind a waiver. That was one of the main takeaways at this point. I think so. Thank you.
Thank you.
Well, from our side, I was gonna point to Beth Catherine. Catherine, did you have any comment for ecology?
Well, sadly, I always have thoughts. And I'll piggyback on to EPA's issue on timing. We know that currently the current plume boundaries certainly, centered around ERDF. But I also recognize that the east side 200 pump and treat will also be bringing iodine 129 from the east side. It will essentially pass through the treatment facility, and that iodine 129 will then be pushed into the injection wells. So where you currently have your nice containment mound that is limiting expansion of the ERDF plume, in the coming years, you could actually start to see concentrations growing around that mound. So when we are looking at what is the boundary of this for a technology limiting, issue, I think we are years away from even assessing what is the breadth of the area impacted by 129, iodine 129.
Thank you.
So, sounds like there's a lot of interest already. I'm gonna start this queue online. We're gonna go Mia, Dan, Larry, and Chris. If anyone else have questions, please flag me down. And Tom. All right, Mia, go ahead.
Hi, yeah, thank you for your presentation. I'm curious if this, the technologies that you were talking about that are not viable, is it specific to iodine 129 in general, just across the site? We don't have a technology to deal with that contaminant, or is it specific to this operable unit, this plume, or is it both?
So we looked just at this contaminant plume. And so, I don't want to make any generalities or anything. So, I don't know much about like the east side. And I mean, the concentrations on the east side are even much lower than what we're looking at just in UP1. But I know that for this TI waiver and the technology evaluation that was done was specifically for UP1, the 200 UP1 operable units.
Okay.
And Dan.
Yes, thank you. In terms of curing, how many curing 129 are we talking about that would be affected by a waiver? And how many of those cures in what time period would make its way to the Columbia? If you know, it's a difficult question.
I'm gonna have to probably get back to you on because I don't have the specifics with me right now.
Okay, yeah, I would appreciate that. Thank you.
Yeah.
So I just real quick to add on that, the modeling that was done is that this particular plume is very stable. It's in a very stable hydraulic, however you say it, an area. So in terms of it reaching the river, that part was evaluated, and there is no time frame in which this particular plume, under the modeling time frames, reached the river.
Okay, thank you.
Larry, your question.
Actually, I have two. The first one is thank you, Kate, for the nice presentation. The first question is related to the plume. We've all been talking about it in 2 dimensions, and this plume has depth. Do we know the depth of the plume? And if that's part A of the question, part B of the question is, are the injection wells actually containing it so that it's going down toward the water table? That's one. And then my second question is, why the delay between the PNNL analysis and your creation of the waiver?
So for your first question, we do find iodine throughout the aquifer, so it's not just in a specific location. So it's about 200 feet, I would say approximately, but aquifer, yeah.
To groundwater.
Yeah. Like, maybe 150 exactly but it does, I mean, it's pretty, I would say, uniform, really. I mean, the plume's been out here for quite a while, so at that time. And so but the injection wells that we do have long screens, they are screened down, and so it does go to the bottom of the aquifer, and so it does do a very good job of
So there might be
treating
some
that area.
push up or.
It's kind of pushing it back,
Okay,
um,
okay.
and so, and like Annie said, it is a very stable plume. Iodine does not like to travel. And that's actually kind of one of the things about extracting it too, is it doesn't want to move, when you try to pull it out.
But it's an iodine, right?
Mhm.
Like sodium or,
Yeah, but it likes to be in the soils. So, but yeah, and that is kind of a challenge too, when you're talking about it being throughout the entire aquifer. You know, that it does present kind of more of a challenge too to pull it out, so.
thank you.
Mhm.
Okay, Chris.
Are there any milestones associated with item 129 that are gonna have to be renegotiated or?
Yeah.
And then Rob.
Before I go, Charles, did you have something?
Yeah, I did, thanks. Legal question for, what would trigger a reevaluation of a waiver?
So,
Circle of 5 years.
yeah, I was gonna say, yeah, these are reevaluated at our circle of 5-year reviews. So every 5 years, we go back through and look at all of our decisions across the site and say, are they still protective? And so once a final decision, a final rod, that refers to them as a final rod, but it's really just a rod, has been made, we'll revisit those every 5 years. And so that's what would trigger this, or of course, if in between, for some reason, we heard there was some amazing new iodine technology that came to our, to our attention, then we would evaluate at that time, but it would generally be in the circle of 5-year reviews.
Okay.
A couple questions. One is on sort of the management area of the technical practicability, because that's the block that's basically no drinking water standard. How is that established when there's an active sort of unnatural flow regime? You know, and as long as those injection wells are there, there's some mounding. And until that mounding goes away, you don't know what the plume looks like. You don't know if it's stable. So how is that sort of worked?
So when we did the modeling, we actually simulated turning those off.
Okay.
And then, looking at how over time with the groundwater flow and then adjusting, when other areas might shut off or how that flow rate might adjust. And so then, that you kind of, look to the future and predict, what you expect could be happening with injection. And then look at the movement, and then you kind of create your boundary around that area.
Okay. And then looking to the future, if we all had our crystal balls of Hanford cleanup progress, how frequently do we anticipate this work to be updated, or when do we think, are we looking decades before this comes to a record of decision with public comment, or should we just get a briefing again in 5 years? What's a good sort of check-in on this type of thing? Because I anticipate there will be other technical and practicabilities on site at some point.
Kind of hard to say right now.
Yeah, right.
With all the evaluations that we're doing, it's just kind of right now, yeah, I just don't have a good answer for you, so. Unfortunately, not that I'm not trying to
Yeah, just
be
trying-
transparent, but there's a lot of moving parts and it does affect when, and because we don't have some decisions, it's just, yeah, presents a challenge.
From a regulatory standpoint, would it be beneficial to have the HAB weigh in on this in its current sort of draft on hold form, or should we wait for a more final? If there's anything.
We definitely consider this on hold to the extent that it will have to be reevaluated when the right timing is identified. So, it has not yet been reviewed by our technical and practicability waiver coordinators who do have to review this. It's been reviewed at my level and our hydrologists. At which point, we had identified those couple of things that really triggered that it's not the right time. We need to wait on this one. And therefore, like I said, I mean, if you want to, you definitely can, and we'll consider them in the future, but I would say there will be an opportunity in the future too.
Okay. I guess homework that I would request from the agencies is when this is getting, a year out, to give us another heads up so we can be timely and. Nice. Can I see you?
My question really asks how deep is this plume? I've got somewhat of a remote question or rather strange question. I know aqueous form, which is what we're talking about here, seems to be a problem, but not in the gaseous form, which is sort of, I believe it's like charcoal bed on rock. So better. So there's no way that could be done with the aqueous. That's what you're telling me.
Mhm. Yeah, currently, right now.
Well, then Chris.
I know we've been working, P&L has been working on getters for iodine and technetium for many, many years. They come up with a number of compounds that, will tie it up and that sort of thing. I guess what I'd like to understand is what was the extent of your determination that's not practical? What technologies did you review to say it's not practical to put a bunch of sodium down in the hole, or it's not practical to put some of the other getter materials down, How far did we go on this to make this determination?
P&L actually did a pretty thorough, investigation, and actually that report is available. And I can get the number and everything.
That'd be helpful.
Okay,
I've seen the 203 report, and then there's a later one in 15, I think.
yeah, this was completed in 18.
And they,
And so we looked at a number of technologies from in situ to ex situ treatments and various forms. And a lot of times one might have been effective, but the applying it or the cost was astronomical. So either the cost of it was going to be astronomical, the application of it, especially being under ERDA, that's what we ran into a lot of these is there was no way of properly getting it down there without, causing some serious issues with ERDA. And that, creates a huge problem in itself. Some of them just during the lab study just didn't work. They weren't capturing enough, they just weren't effective at getting the 129. A lot of times 127 was the one, because we have a lot of 127 that's stable. That was what was latching on to a lot of these technologies, whereas the 129 we don't have a lot of it in that ratio. And so it did create an issue, but we looked at those three things of the effectiveness, the cost, and then the implementability. And those were the three factors. And unfortunately, there wasn't one that kind of hit all the marks.
so what is the risk profile for iodine 129? Because it's this long half-life.
That's.
Some of it's like, yeah, the current drinking water standard, as I mentioned, 1 picocurie per liter. And that's based off of I think it's like the 1969 handbook. But I'm not too familiar with risk profile. I mean, and part of this being protective, if we had a waiver, is that it would continue to not be a drinking water source, right? That goes along with it, so.
Thank you.
Right, so we have Chris and then Tom. Keith.
In the various monitoring wells, are there any trends of item 129 activity concentration at all? Either decreasing, increasing, or are they pretty flat?
They're pretty flat. This is pretty stable. And so we don't see a lot of changes. On some of the edges, they have kind of shrunk back. So the plume's kind of gotten more concentrated, and some of that could be just the injection well water pushing it back inwards. So you're kind of shifting that edge westward. But then we also have injection on the west side, and so you're containing, that plume wants to go east, and so you're kind of keeping it there, but really, we haven't seen huge changes over the years. It's remained pretty stable.
So you're not saying dilution from the injection, water injected, kind of counteracting the concentrating.
Just maybe right on that leading edge, but otherwise, at least in more of the center of the plume to the west side, we're not seeing that much.
So, just a point of clarification, I'm not a lawyer. In my past life, I've been told by some lawyers when I was working with technical impracticabilities, that the difference between practical and practicable, this is an impracticability, not an impracticability, impracticality. If it is possible to remove the iodine, you have to, regardless of cost. So because ERDIF's there and because you have, maybe the other iodine loading the treatment, so you're not actually getting to the stuff you want, that's what's causing the impracticability, not the cost. So, just want to make sure that we're saying this is impossible to get, not expensive to get.
But we wanted to be transparent too and look at the cost because it does become a factor. We want to make sure that we're being efficient in all areas too, so that wouldn't be the sole factor though.
Any other questions? Here it is. So it's 200 feet below grade, this plume, or this groundwater plume. And you got earth on top of it. Is there anything that would prevent going outside of earth and then do some horizontal drilling like they do for oil to get at it? I mean, that's. Yeah, I mean, that seems to be an approach to get at the plume or the groundwater and maybe treat it step away from the station.
Yeah, that would be something that, I mean, you would have to consider ERDA because I don't think.
You spoke to the XC2 treatments
Yeah,
as
and-
well were looked at in the P&L report, and those unfortunately also had challenges that were overcome by like the amount of the iodine 127, or they weren't the right speciation of the iodine itself. That was getting grabbed to the point where they actually thought if they pumped out the water and treated it like at the pump and treat facilities, we put in another train or something. Right now, we didn't have a good technology for this groundwater condition. So even if we were to access it and pump it out, because we did ask that, and we didn't really like the answer so much that like, we're just because ERDIF is there, we can't treat the groundwater, right? But there were enough other challenges around it that together they collectively made it so that none of the alternatives work.
Seems like it'd be hard to position a screen after horizontal drilling to get the full aquifer extent if it's also evenly distributed across the whole water column. Yeah.
Pretty sophisticated at going around it.
Right. Fair.
So,
Fair.
and so we have a lot of iodine 129 in our Earth's crust naturally. Okay, and so it just, we're paying attention to that, right? We have a background here away from where we put it in now. And I know in the commercial nuclear industry, we use a little bit of activated carbons to trap the iodine. Okay, and
That's in the catastrophes for.
that's right, but it's activated charcoal or turning it into the gas too. But yeah. It's ubiquitous. It's everywhere.
Any other questions or comments for our guests? If you're online, you can raise your hand or comment in the chat. Then we can speak up. I think that's it.
Okay, well, thank you so much for the conversation and enlightening us on this emerging but on hold topic. Essentially, yeah. I realized we didn't do it around the room and introduce ourselves, and we have a little bit of time before the agenda says break, so we want to jump out of order and do that.
So I suppose I can lead that. My name's Josh, support the Habit Facilitation Team. This corner, Bob Pork, member of the public, go around the table.
I'm Brian Miller, the Communications Manager for Ecology.
Rob Davis, I represent the city of Pasco.
Tom Cecilia, Oregon Department of Energy.
Rebecca Holland, I represent Hamtech.
Jen Colborn, DOE.
Colleen Drinkard, HMIS, supporting DOE.
Mackenzie Kaloy, contractor supporting DOE.
Larry Grant, member of public. Dr. Presty, Legal Voters.
Chris Fenton, local environmental interest.
And along the wall,
And McCartney with EPA. Naomi Jassy.
I'm just Washington State Department of Health.
and I'll run down our teams list as I see them. If you'd like, you can open your microphone, introduce yourself, starting with Ken Bristol.
And
Kevin
Alvarez,
Manby. Go ahead.
College.
Go ahead.
I was going to say Kevin Danby representing Grant and Franklin counties. Thank you.
Dan Solitz, public member.
Moving down the list, Alicia.
This is Alicia Boyd with Department of Ecology.
Think you're ready there for a second, Roberta. Okay, jumping down, we have Catherine.
Catherine Glick, Nuclear Waste Program Lead Hydrogeologist.
Dana. Michelle.
Michelle Jones, Department of Ecology.
Jane. Matthew.
Matthew Campbell, Confederated Tribes, the Umatilla.
Mia.
Mia Burke, Hanford Challenge.
Susan. Is everyone?
Okay, that took some time. Our schedule calls for a break at 2:30. It is almost 2. Should we move some more stuff around?
Committee business?
I'm assuming Gary's gonna be closer to when he's actually scheduled.
So I can try and reach out to him, but no promises.
Okay.
Yeah.
Well, let's take a couple seconds so we can let people leave if they want to leave. And then we'll get into some committee business, I guess, to fill the time.
Jen, can we get access to the PNN report?
Yes. Yeah, right.
Sorry, so.
Yes. Provide them.
We can get that link confirmed, we'll potentially put that in tomorrow's weekly update.
Excellent. Okay. So there's some things to talk about for committee business, and one of them is the work plan, which we, as a board, typically go through once a year, and we have a leadership workshop in the summer and determine what the board's talking about in the next year. This year, the leadership workshop is in June.
Yes, we have a committee week where we have 2 committee meetings right ahead of that leadership workshop.
Okay, so I just want to put sort of the bee in your bonnet. Start thinking about that now, because by the time we have our committee meeting in June, there's not gonna be a lot of time to turn around sort of our requests. And what I can do is look back on the past requests that we've made and see what might still be valid. And I can send that around, as a sort of opening salvo. And then, any other things that we have that come up today or, in the coming weeks, you can send them to Josh and me, and we'll compile that list. My short list has, the milestones for M15 and 16. which would be the investigation and cleanup milestones for all the major facilities and operable units. There's some canyon disposition work that's being done under action memos and non-critical and critical time, non-time critical removal actions that there's no real reporting requirement until that work's done, but it would be good to get an update on sort of how things are progressing. I think when Jason Caden was in a couple meetings ago, we had sort of a conversation and he went through the whole site and talked through where everything is sort of informally, and I think that might be a good annual occurrence to keep on the list, which might cover a lot of this. And then we've been asking for the uranium sequestration study in the 300 area, which I think in 2018, 2019, there was an injection to sort of encapsulate uranium right at the top of the water table in the periodic rewetting zone to keep that uranium from getting to the river. And I'm watching for a study on that since then. Those are the ones high on my list. Chris, what do you got?
Might consider having a groundwater 101 again. Mike Klein gave it 3.5 years ago, and we've had either 3 or 4 orientation periods since then. So there's a lot of members on the HAC who have never heard of, got a really good overview.
Yeah.
And so a groundwater 101 might be timely again to consider.
Other ideas for the next fiscal year?
If I remember correctly, was it this committee, subcommittee that was gonna look into, understanding risk? And the risk of what it is and
That's a
how
joint.
we evaluate it and, how, for example, with iodine.
Yeah.
Geez, as long as it's always down there and it's not coming out, it's.
So that's a joint topic that we have with CO. It's on this year's work plan. The agency's requested advice. We had sort of a framing session on it. When was that? Last year?
I think it was October.
October of last year or so. So we had a big discussion about what risk meant to us and what we think that the agencies how they communicated. So that obviously we haven't written advice on that. We were waiting for some direction. It wasn't ripe at the time. So that could still carry forward.
And I know that some people are actually using, calculational methods to determine a normalized risk for certain things. And it'd certainly be nice to see that used at least, or examples of it, or and so is it even appropriate for our site or not?
I'm old enough to remember, actually, I think it was my first HAB committee meeting where Doug Shute came in with something called a risk matrix. And he actually had an Excel spreadsheet of all of the different facilities on site and that this is the highest risk and this is the lowest risk. And, so maybe something like that would be an interesting discussion.
Yeah. And the components of risk that went into determining high and low.
The other thing that I was thinking, we're hearing a lot about the tank farms and cleaning those out and emptying the tanks. But the soils underneath those tanks with contamination in them is sort of the nexus between tank waste stewardship and treatment and our committee. So maybe trying to have a discussion or presentation on what's known about soils under tank farms writ large. And then maybe as the tank farms get closed out with WMAC or something like that, we can have a conversation about what's left under the tank farm.
Dan might have a suggestion.
Dan.
Yes, thank you. This is regarding the reactor moderator coolant sodium that's stored at the Fastflex test facility. I think it was a planning document in 23 said that they were supposed to start planning a facility to treat and contain that, treat that. and so it's not as hazardous in its form that it's in right now. And then at the next planning document, that dropped off of it. So we could look into that and make sure that they keep going on that. There's a lot of interest in sodium as a coolant moderator around the world, and I think it should be, people should know what it costs to deal with that stuff after you're through with it. It's all the sodium there isn't specifically from the Fast Flex test facility. We've taken in sodium from a lot of areas. Idaho has a lot of sodium. And so if we could get someone to give us a presentation on that, I sure would appreciate it. Thank you.
Okay, yeah, I think that came out around the time of the environmental engineering assessment and engineering evaluation and cost assessment for the FFTF facility, which would have been July, August of last year. So that's timely, and I think that's a reasonable ask. The action memorandum for that removal of the buildings is public, so like to see where that's going. Yeah, thank you, Dan. Anyone else?
Thank you.
Getting on the ground floor of the request before we talk again in June.
We're gonna talk about sodium, we should talk about the recycle thing. You know, the reuse of it.
Yeah,
Yeah.
yeah, beneficial reuse opportunities.
Well, at one point, I do remember the WTP had such a large volume of sodium hydroxide need to wash and to treat the high level waste that much of that would have been converted into a liquid form and used in WTP. But that was pre-treat questionable, and the washing and all the other treatments that were going to be done. Just we're not going to do that anymore. Try to feed HLW.
Okay, so throughout the rest of today's meeting and the next couple months, keep thinking about it and jump in if you think of something. I'll move on to the next thing I have on committee business, which is nominations for chair and vice chair. We don't have our vice chair on with us today, but I don't know whether he's interested in serving again or willing, so, but I highly recommend, if you're interested in getting more involved, that you throw your hat, name in the hat, one of those words. It's you know, you're not always just shouting into the void. Sometimes you actually can make some differences, and good way to get to know things. We need nominations by the next committee meeting, which is in June, correct?
That is the goal. If you want, this committee wants potential new leadership to participate in that leadership workshop. We would want to know who they are by June.
Yeah, so what happens is if you can self-nominate or you can nominate someone else. Facilitation would then check with that person and make sure they want to serve. And then make sure they're eligible to serve, because only primary members can serve in committee leadership. Which is different, you know, this year and next year moving forward, than we've done in the past, but that's what we're doing. And so you would be, once you're an official nominee, then you would get all of the leadership workshop invites and email correspondence to sort of your intelligence briefing, so to speak, as you're a candidate. Yeah, it's a lot of fun. Well, that earned almost 10 minutes.
Don't know, he just left the office, so probably 10 minutes.
Okay,
Perfect.
perfect. Let's take a break. And then when we get back, we'll have a brief and appreciate him coming early.
We'll have time for dinner.
Right? 10 minutes? 15 minutes. Let's do 15 minutes.
Okay, we'll return to that 2:25.
Hey, Jim. Here's this.
Live again.
Okay, welcome back, everybody. Hope you had a good break. So we're gonna have a presentation on one of our favorite topics, the waste encapsulation and storage facility by Gary Hiles. And look forward to a good conversation. Floor is yours.
Okay, thanks. Well, again, my name is Gary Piles. I am the federal project director for the cesium and strontium dry storage project, also sometimes referred to as the W135 project. Next slide. So today I'm just going to give you a quick briefing on where we're at with the project. I'm going to touch base a little bit on the project mission, walk you through the capsule transfer process, and then we'll get into kind of where we're at with the project. I'm actually going to cheat a little bit. I've got a 5-minute video in the presentation that we'll go through. It's going to actually walk you through kind of the history of WESIF, why we're doing what we're doing, and again, kind of walk you through that process, kind of a high or general overview. I think for most of you, I think you've probably seen me present before, give status, so it's the same video, but it's a good kind of refresher. So we'll show the video, and then if you have any questions, answer them after that. Yeah.
The U.S. Department of Energy and contractor Central Plateau Cleanup Company are reducing the risk in the 200 East area of the Hanford site in Washington state. Engineers have developed a safe and compliant process to remove 1,936 highly radioactive cesium and strontium capsules from underwater storage inside the Waste Encapsulation and Storage Facility, or WESIF, to a safer dry storage configuration. In the 1970s, cesium and strontium were removed from waste tanks at Hanford to reduce the temperature of the waste inside of the tanks. The capsules represent about a third of the total radioactivity on the Hanford site. While they are currently in a safe configuration, WESIF is an aging facility. Transferring them to dry storage would eliminate the possibility of a release of radioactive material in the unlikely event of a major earthquake that might result in the loss of pool storage water and subsequent overheating and breach of the capsules. Teams of well-trained personnel will accomplish this work safely and compliantly, benefiting from the lessons learned and proficiencies gained from training with the equipment at a full-scale, non-radiological mock-up. To begin the removal process, workers on a catwalk will use long-reach pole tools to access the capsules that are stored under 13 feet of water, which provides adequate radiation shielding for the workers. Workers will retrieve the capsule and move it to the transfer chute connecting to the hot cell, or G cell. From outside G cell, workers will use manipulator arms to bring the capsule near a shielded window to inspect the capsule for damage. They will also verify the capsule's identity to ensure the correct capsules are loaded in such a way to comply with the capsule storage thermal analysis. If operators find a damaged capsule, they will place it in a larger overpack capsule. Then, workers using the manipulator arms and a special insertion tool will place the capsule into a universal capsule sleeve, or UCS. The UCS can hold up to 6 capsules. Once the UCS is full, the air inside will be displaced with helium, which helps dissipate the heat from the capsules. Following a successful leak test, the UCS is ready for transfer to the truck port. Using cameras, workers will guide a grapple over the UCS, hoist it out of G-cell and into the Shielded Dry Transfer System, or DTS. The DTS is a large shielded cask that will transfer the UCS from G-cell into the WESIF Canyon to the truck port, using a 15-ton crane. In the truck port is an 11-foot tall, 10-foot diameter cask shielded with reinforced concrete. In the cask is a storage container capable of holding up to 22 universal capsule sleeves. A robotic welder will seal the lid of the inner storage container. The air will be removed, and then the container will be filled with helium to aid in keeping the capsules cool. Once the helium is in place, a second outer lid will be placed on the storage container and welded in place. Once the loading process is complete, workers will open the truck port roll-up door and remove the cask. The equipment used to transport the cask has been repurposed from a previous DOE project, avoiding millions of dollars of cost. The vertical cask transporter, or VCT, a specially designed hydraulic lift unit, is used to lift the cask. The tug will tow the VCT and cask to the capsule storage area, a 90-foot by 90-foot secure outdoor storage pad located approximately 1/4 mile from Wesif. The cask will be placed on the pad and will be connected to a temperature monitoring system. The cask will be placed in one of the 25 locations on the pad. Once the final capsule has been retrieved and the final cask has been placed onto the storage pad, Wesif can be prepared for demolition. These cesium and strontium capsules will remain in a safe and passive condition until a permanent storage location is available.
Okay, any questions from the? Or you can ask them at the end. All right, so next thing I want to go through is kind of the project structure and give you a status on where we're at. So the bullets here kind of highlight the different activities that were done to support this whole effort. I started this project, I think, or came onto the project at the end of FY18, early 19, and so we kind of, by the time I got on, they were getting done doing all the design work and getting everything approved. And we started construction just as COVID hit. So, but even despite that, we still made a lot of progress moving forward. September, or basically the capsule storage area was the facility, of course, that will be where the vertical concrete cask will be stored. The construction of that was completed in the fiscal year 22. We did, again, as mentioned in the video, we had a full-scale mock-up that was built over at the maintenance storage facility, massive. Basically represented the 3 different areas within Wesif that we were going to be operating in: the G cell, the truck port, and the cannons, right, in the truck port. That was constructed, and then we had basically test articles of the transfer equipment were installed. That work was completed in FY23. Since then, of course, we've been using that facility to continue doing training, help develop procedures, get the operators kind of proficient at the capsule transfer operation. We also worked pretty hard on doing the Wesif modifications. Basically, we had to modify the facility to be able to get it prepped and ready to actually install the capsule transfer equipment. This was moving piping and stuff away to be able to give have enough room to get the VCC into the truck port. And you'll see in the picture, there's only like about 1.5 inches, 2 inches of clearance on either side as you move this big piece of equipment into the truck port. We had to reinforce the flooring to be able to support the weight, put HVAC systems in the 3 different areas we operate to help keep the area cool when we're doing operations, and then installed all the conduit and piping that's used for the compressed air system and for all the electrical components that all the way up to the that connect to the control panel. That was also completed in FY23, and then once that was completed, then we were able to then move in and start installing the equipment. The cask storage system, that is the actual fabrication, installation of all the equipment that was done. Again, this included both the test equipment that was installed at Massive, as well as the production equipment that was installed at Wesif. It also included fabrication of the storage system itself, the cask, transportable storage container, and all the universal capsule sleeves. So all that was delivered. We have that on site. All the equipment has been installed and tested over at Wesif. That was completed last fiscal year. And so that kind of got us into a good position to be able to do all the readiness activities this fiscal year. And so that's what we have planned. There's 2 different readiness activities being done, one over the CSA and one over at Wesif. Basically, what readiness activities entail is basically once the facility was transferred over to operations, they then were able to go through using the equipment, walk through their procedures and validate procedures. finish up training, finish all the paperwork they're doing, they needed to get done in order to prep for the readiness assessments. And so over the CSA, that work has all been done. They've already started the assessments. In order to operate a nuclear facility, there's 3 assessments that need to be completed. In order to, and this is all again to make sure that they're proficient and everything's aligned before we actually start working and moving highly radioactive material around. So the first one is a management self-assessment. That's done by the contractor. Their management, basically the operational management group will go in and make sure their operators are proficient, do demonstrations, make sure practice upset conditions, things like that. Once they've declared they're ready, then they kick off a contractor readiness assessment. And so they'll have an independent group come in and basically do another full-scale assessment, have them do demonstrations, practice upset conditions. Again, all in an effort to make sure that overall they're ready for the final assessment, which is DOE. And then DOE will come in and also do assessment. So it's quite a long and tedious process, but we're going through it. As I said, at CSA, there's completed the management self-assessment, started the contractor assessment this week. The plan is to get that done and be prepped and ready for the DOE assessment at the end of April. For the WESF, they're still going through the procedure validation of the welding system, still finalizing the training. They're hoping to start the management self-assessment at the end of March, or basically April timeframe. That will roll into the contractor readiness assessment June, and hopefully the DOE's assessment then kicks off in August. So that's kind of our schedule for this fiscal year. And the whole point is to get the DOE's letter approving the startup of operations by the end of this fiscal year, and that sets us up to roll into actual operations in FY26. So for operations, we're assuming it'll take about 2 months to load each vertical concrete cast. Those 18 total, 12 cesium and 6 strontium. So we'll do the cesium first. The idea is to get done with all 12 or get in 26, 27, do the cesium, and then roll into the strontium in 28 with a goal to try to get done by the end of fiscal year 28. So that's our schedule. So now I'll just kind of go through some of the pictures here. Some of this was discussed on the video. This is this capsule storage area. Picture on the left is just kind of an aerial view. Picture on the right, back in April, we had received all of the vertical concrete tasks, and so there they were, all 18 of them. Next slide. So the picture on the left, on the bottom left of that picture, you see those yellow or white cylinders. Those are actually the transportable storage containers. And so those are basically being inserted into the vertical concrete cast. So the crane has basically got this kind of skirt that we would put down into the vertical concrete cast, and that would help load the transportable storage containers into the VCCs, make sure that we basically put them in without damaging the containers. So we inserted all 15 of the 18. 3 of them are still being stored at CSA. 3 of the VCCs are being used to support the demonstration activities that are being performed for the readiness activities. So once readiness activities are done, then they'll insert those last 3, and they'll all be prepped and ready to be used at WESF. Picture on the right is the vertical transporting system and the tug. And as you can see there, it's got a VCT. And so they've demonstrated this operation many times out of the site. In fact, that's what they were doing today as part of the contractor readiness assessment that's being performed. And so, yeah, they're getting pretty good at being able to move those around and put them exactly where they want. So, next slide. So this is a picture outside of WESF. On the top, that's the vertical cast transporting system. Basically, moving or placing a vertical concrete cast onto the air pallet that just sits outside the truck port. Picture on the right is actually the VCT on the air pallet. On top of the VCT, there's a shield ring that goes on. That's kind of help provide shielding for the workers as they're doing capsule transfer operations inside WESF. And then the bottom left there, that's actually it just moved the VCC into the truck port. See the air pallet. As you can see, it's a pretty tight fit. Okay, next one. It's yours. Next slide. Picture on the left, that's the control panel. That's inside the operation gallery at WESF. This is where they'll basically operate all the equipment, both and G-cell, as well as the equipment up in the canyon. And you see all the monitors they have there. Like they said in the video, they have cameras positioned throughout the facility, so they can the operators can use that to help the operations. The one in the middle, those are operators training, moving dummy capsules in the pool cell. Again, this is where they'll move the capsules and place them into basically an elevator that they'll use to lift them up into G-cell. And then on the picture on the right is just an operator using the manipulators to place a capsule into the universal capsule in G-cell. Next slide there. So the picture on the left, that shows a universal capsule sleeve, one that's been loaded with dummy capsules, of course, at this point, and it's being lifted up into the canyon. Picture on the right, or on the top of the right, that's the dry transfer system. So that's basically butted up against the G-cell gate. So right below that is where the dry transfer system is G-cell, and so basically the grapple will lift the universal capsule sleeve up into the DTS. The gate will close, and then using the crane, they'll move it over the top of the VCC in the truck port. The bottom right, so pick the equipment to the left. That's what we call the recovery shield assembly. So in the event that we're loading the universal capsule sleeve and the upender breaks, or we have an issue with the upender, we have two options to be able to recover. One is we could actually dump the capsules out of the universal capsule sleeve and then drop them back down in the pool cell. Or the other option is we can put them into this recovery shield assembly. It's like a big leaded clamshell. We can actually push the universal capsule sleeve into this shielded assembly. It'll close, and that provides enough shielding that we can then get somebody into the G-cell to do the repair if needed. Next slide. Okay. So the picture to the left, it's kind of hard to see, but on the very left side is a dry transfer system, and it's actually attached to the vertical cast transport system below. Picture on the far, I'm sorry, on the right, top right, that's the shielded the shielded indexer assembly. That actually goes on top of the VCC. So once the VCC is into the truck port, this piece of equipment will be loaded on top. It's got a gate that's very similar to the gate that's over G-cell. That gate kind of rotates around to the 11 different chambers that line up with the chambers that are in the transportable storage container. And so again, they put the dry transfer system to that gate. It opens up, and then it lowers the UCS into the transport into the VCC. Once it's fully loaded, we remove that that shielded indexer assembly, and then we put the inner lid on. Basically using that automatic weld system. There, the picture there on the left, that will move over the top of the VCC, drop down, and then do the welds. There's basically 3 welds that are done. We have an inner lid. The welding machine will be used to center that lid and then do 3 passes. On the inner lid, there's a port valve. That's again what's used to draw the air out and backfill with helium. Once that's done, we'll put a weld on we'll put a cover plate will be placed on top, that'll be welded. And then we have an outer lid that then's placed on, and that's welded on. So, once that's done, the outside, the cover lid on the VCC will be bolted down, and then it will be ready to be moved outside. And so, just following the same process as getting it in, we'll just pull it out and use a VC to get it out. So anyways, just wanted to highlight, some of those pictures kind of highlight all the equipment that's there. There's been a lot of work going on. The readiness activity is not an easy task. There's been those folks have been put a lot of time out there to get ready, do all the training, making sure the equipment's operational, they're maintaining it. They've been working extended shifts Monday through Friday or Monday through Thursday, additional shifts on Fridays and sometimes on weekends to try to stay on schedule. So they're putting a lot of work out there, and hopefully, again, by the end of this fiscal year, we'll be ready to operate. Again, key takeaways, again, significant progress is being made, and ultimately, as mentioned in the video, the end goal is to then shut down WESA, and the money that's currently being used to maintain that facility can then be saved. We'll see a saving of about $6 million in annual operating. So,
Thank you. Let's go to ecology.
Yeah, I know we have both John and Michelle. John, were you going to provide some comments?
Michelle.
Okay, Michelle, did you have any comments for ecology?
No comments, but I just want to say that ecology is very supportive of the progress that's been made so far and looks forward to the capsule transfer starting in fiscal 26.
I think we lost EPA.
Yeah, just double check. We have no from EPA.
Okay. So we'll jump into the queue.
Yeah, we have a queue of 3 so far. It goes Dan, Tom, and then Mia, then Chris, then Rebecca. Dan, lead us off, please.
Thank you. Could you talk a little bit about the lead capsule project is going on along with this WESA, and also the ultimate disposition? I guess there's 3 possible paths: deep geologic disposal, making it into high-level glass, and putting it in a borehole. So, is it thinking on that matured any at all? Thank you.
Sorry, I didn't catch the first part of the question.
The lead capsule project, I understand they're putting a capsule out there that's empty just to assess the environmental effects on the capsule itself. But I'm not quite sure for what reasons.
Yeah, so we have so remember there's 18 total capsules. We do have a 19th vertical concrete cask and transport storage container, and we're going to be using it as part of an aging management program. We have some heating elements that we'll put inside that replicate the basically heating that we would see from the capsules. And the idea is to be able to do kind of a long-term study to see if the heat or something has any impact on, or if we see any issues with the transportable storage container inside. These things have been designed, I think, to last up to 300 years. But our nuclear safety documentation, we only take credit out to 40 years. And so this aging management program will actually help us build the case to be able to defend extending that life expectancy that's in our nuclear safety documents. I think that's what you asked, and it's still kind of, and I know they've been working with others around the complex to help build the case also for some other casks that are being stored, at other facilities. As far as disposition of these, there's been no disposition path right now. They're just will be placed out there in interim storage, something that we will have to do at one time. We have kind of looked at different options, but nothing has been selected yet.
Did that answer your question, Dan?
Thank you. Yes, thank you.
And there was a preliminary disposition analysis published a year or two ago. Maybe we can get that added to our minutes just so it's there.
Yeah, I think we have a milestone with a TPA milestone every 4 years to update it. It just looks at options of we consider it true, could we get it there? If we consider it high level, how would we do it? Or if it's low level, yeah. I think we could get that.
Thank you for the presentation, really informative as always. So when we were out at Massive during the orientation tour last year, so I got to see the robot welder working for the first time and really cool stuff. I seem to recall though that the sleeves were sourced from Canada. Is that accurate? And if so, have they all arrived yet, or do we still have to buy them?
No, everything has been delivered already. The welding system actually is from Liberty, which is like from Canada, right? So they built, I mean, all the equipment has come from all over the place. So we had a lot of different vendors from all over the country and from other countries supporting this effort. The transportable storage containers, those actually, and the insert, the aluminum insert that has the 11, that actually came from Japan. And then except for the welding machine, it's from Liberty of Canada. The actual concrete cast, the pedestals were built out of Peterson, I think was the name of the company, then in Salt Lake City area, and Nays, I can't remember their acronym, but they came in and did the concrete work. So yeah, we had quite a bit of support. The actual universal capsule sleeves came from ABW, I believe it is, on the west side of the state, company on the west side. So that's dedicated to everything.
And then if the stars align and all of the analyses and the 3 different studies get completed for WESF prior to the end of this fiscal year, and the work can progress safely, are you ready to begin this fiscal year if the schedule makes it?
So if we can get through all the readiness assessments before the end of the fiscal year, then there could be a chance. But I know, like I said, that those assessments take time. And so right now we're just shooting for getting at least the letter for approval. I think even if we got it, I think the contractors might take, once they get the approval to start, may take a little bit of time, readjust, right, and then take it slow the first one. And then as they start progressing, then we'll see, we'll be more efficient, we'll start going faster and faster. But yeah, I would say probably most likely they will start on over time frame.
Excellent. Next question comes from Mia.
Hello, thank you for your presentation. I have 2 questions. My first question is, now that you have a better idea of when the capsules will be transferred and the end date, have you renegotiated that with Ecology and the milestone?
Yeah, so we're still in progress with finalizing the change control form and negotiating that new milestone. I think and so I think we're close. We're close, but yeah. For the next few months. Yeah, we kind of knew we had to renegotiate the milestone for some time now, but we were kind of waiting until we get more information from the mock-up and from operational group as they're going through and doing their training to kind of understand the timing for loading. And so, yeah, now that we have that, we are working with Ecology to negotiate that milestone.
Okay. And my second question is about in December, there was a discovery that the WESF G-cell door that provides shielding to workers may inadvertently open during a seismic event. And I'm curious what is going on with that? How are you tackling that issue? And has it put you further off track in terms of the schedule?
Yeah, no, it was during, as they were going through the process, I think they realized that the engineers group realized that there's a potential that in, like you mentioned, a seismic event, that the latch could become ajar and the door potentially could open. I think this is an issue that's not a result of anything we did. I think it's probably been something that just never been discovered until just recently. So there is a path forward. There's a design that has been developed to add basically like like you have like the gates outside, they have that pin that drops down into the concrete. And so basically design work is done. We have to update our safety documents, which is being developed right now to reflect that new design. And so we've got that built in our schedule. So right now, it doesn't look like that's going to have any additional impact to the meeting, what, the schedule I just mentioned.
Okay, great. Thank you.
Chris?
I'd just like to make sure I'm clear on some of the numbers that you articulated. So there's 6 capsules that go in the universal capsule sleeve, right?
It could be, yes. So we have,
But I'm sorry, go ahead.
yeah, not all universal capsules will have, also we have a specific load plan. And so there may be in some cases where we may put dummies in with the capsules, so to help make sure that we maintain a specific heat load in the VCCs. So, yeah, we can get up to 6 in a capsule, up to 132 in a VCC. But like I said, not all VCCs will have that many because we do have a specific load plan.
And how many VCCs then total are you into? I can't, in my head, divide 1,900 by 132.
Yeah. We're gonna have 18 total.
Okay. And you said approximately 2 months for VCC?
Yep.
Okay. So that's
6 a year for 3 years. Is what we're
okay.
shooting for. Yeah.
So you'd really have to be moving to get it done in 2 years once you start.
Oh, yeah.
Yeah.
Yeah. That would be a challenge. And like I said, that's what we're planning right now. As we get more proficient, we may be able to cut that time, but you gotta count too. It's not just the loading. In between the loading each VCCs, there's some maintenance activity needs to be done. And so that accounts for that as well. Right now, right? And then of course, if you have an upset condition or something that you're not planning for, that could cause some impact. So, yeah. But the 2 months is basically includes some of the downtime needed between VCCs to do some maintenance activities.
So just multiplying 18 VCCs by 2 months, that's 3 years. So if your plan calls to get done in 2 years.
No, 3 years. We're gonna do 16, 17. We'll do the cesium capsules in 16 and 17. And do the strontium in 28, sorry. 26, 27, and 28.
Okay.
Yeah. So
have Rebecca's question, then Rob.
Yeah, thank you. I really enjoyed the video that you showed. I actually wish that more of our presentations had stuff like that because it's really, engaging and it's good to be able to, to see exactly what's actually going to happen. So first of all, I'm interested in the video talked about how once it's moved up to the pad, it'll be hooked up to a temperature monitoring system. So I'm curious, is that actually on the pad or is there something that connects to the VCC itself?
So on the VCC, the vertical capsule transporter, there's some conduit already placed, and on the top 4 vents, there's 4 vents on the bottom and 4 vents on the top, and that allows for that passive cooling to occur. On the top 4 vents, there's a temperature monitor. There's basically a temperature gauge that will monitor the temperature. When they bring the VCC to the pad, there'll be a spool of wires that will be already connected to VCC. They'll take that, they'll run that through a conduit underneath the pad and then make the connection to the temperature monitoring system. And so basically they'll monitor that temperature. And what they're really looking for is if they see a spike an increase in the temperature, right? It could mean that the the vents may be plugged or something, so that'll be an indicator that we'll have to go out and take a look and see what's causing the spike rate. So.
Interesting. And then I had a crazy thought, just because sometimes I do, but I just remember a few years ago, I was having a birthday party and I was trying to find helium to blow up balloons. And there was a shortage on helium and you could not find helium anywhere. So I'm curious about, since these are going to be cooled, you're going to be injecting helium into them. I'm wondering what the outlook is, and if that situation, whatever, I can't even remember what it was, but it was interesting to say the least. But do you foresee another helium shortage where this could actually put a damper into how you're cooling those?
Yep. Good question. That I don't know. I'll have to look into that. I didn't think about that. As far as I know, I haven't heard of any helium shortage that would impact this project right now. So that's something to look into.
I mean, it ruined my day. I couldn't blow up the balloons,
Well, and then of course the helium that we're using has to be specific quality, right? So it's got to be like 99.95% helium. So yeah.
Yeah.
We have a question.
I have lots of questions, but, what materials are being used for the capsules? Is all stainless?
Yes, it's bulk of the containers are stainless, and then there's the helium zinc block that's inserted into. So the UCS is stainless steel, but then there's an insert that goes in that's aluminum, and then that's designed to have the 3 chambers that we'll put in. And then same with the TSC transportable storage container, that's stainless steel, but it also has aluminum zinc block inside that has the 11 chambers.
How high temperatures do you expect it to get?
I should have this memorized, I think. So, I believe on the outside of the VCC, the temperature is expected to get about 150 degrees. Our load plan is set up so that the temperature inside doesn't get any greater than, I want to say 318 degrees for the cesium and like, I can't remember, 500 degrees for the straw. I'd have to get back to you on that, but
Okay, yeah, 500 is pretty close to melting.
yeah, we want to stay below that. So that's the max temperature. And of course, our load plan makes sure that we stay well below that. And of course, all our calculations are pretty conservative. So
one of the things that sent me back looking at the ESR, the Provisional Safety Analysis Report, I was looking for calorimetry data, and my concern when I hear that you're gonna, after you get through filling all the holes, well, which is another question altogether, but after getting them all out there, you're gonna demo the Wessex facility. So if you ever have a problem, how are you gonna fix it? Is you taking away the hot cells, you've taken away the all that equipment you have in the Wessex facility won't be there anymore. And so how would you end up handling such a thing?
well, like I said, the vertical concrete cast and all the components are designed by NAC, and NAC has a lot of history with these type of casts. Because these are basically very similar to what is used for spent nuclear fuel around the complex.
What's NAC?
No, I'm sorry, NAC is the company that designed and built the vertical concrete cast, and that company has been used all over the world to design these type of casts to hold spent nuclear fuel. So, as I said, they've been designed to last up to 300 years. So, with all the engineering that's going on, we don't expect to have any issues. That aging management program, that 19 cast will help evaluate. If we see something, we could use that to just help look at options for how we would recover or do repairs or do things like that. So,
okay.
And you got to also remember, cesium and strontium has a relatively short half-life, 30 years. So You let it decay down, 30, 60, 90 years, and then you don't quite have the same issue as you were right to.
Right, well, we're working on 30 now.
Yeah, yeah.
The first 30. So then, for a while there, we were told that we were going to, stage the capsules such that we would be mixing the strontium with the cesium capsules in order to even out some thermal loads and et cetera. And then we heard recently that somebody is interested in buying the strontium ones, and which we all think is kind of ridiculous. But still, so is that the reason why you're segregating them now, is in preparation to the fact that somebody may want you to open those up again and extract out some strontium capsules to?
So as far as I know, there's never been a plan to commingle them. Strontium and cesium are always going to be packaged separately. We have altered our plan slightly. We were planning on doing the strontium first because they're not as radioactive, right? So it's kind of better to start with the easier ones, right? But we did adjust slightly to be able to accommodate potentially those that may want to reuse some of the strontium. So that's why we did kind of focus on the cesium first. There's been no set plan yet on how or who would or how many or the strontium capsules they may want, how we would get that to them. So right now, we're still staying the course and moving forward with our plan. The thing is once we load them into the VCC and do that well, it's going to be very difficult, very challenging to get going into them. Like I said, we won't have, even at West now, we don't have the capability to cut back into wells. I mean, we do have the ability to grind out some of the well, to do repairs, but not to cut the whole thing out. So it would be a huge effort to try to get the strontium capsules once they're loaded. So the idea is if there's like the Department of Defense would like to have some capsules, we've got to probably figure something else sooner than later.
During the late 70s, we were very much into the separations of the cesium and the strontium for the food irradiator. And so the size of the capsules and the dimensions were essentially sized to fit into food irradiators or radiators at airports that would scan, food, I guess. So at the time, I just don't recall the effort that went into selection of materials that the capsules are made out of themselves, and the welding that went into them, and that's, like I said, over 30 years old, and we were doing a lot of ASPE work then, and so anyway, I'm just really difficult to understand why we don't have a safe if something happens. And we're very sure of our engineering, and we're very sure of our plans, and that's when we get hurt most. Hey, thanks a lot. This is a great talk.
Any other questions for Gary?
Simple question, Gary. Looking at the photo of the capsule storage area, so that's near Wessup, is it closer to the cancer storage building? I'm just trying to figure that out, where that is actually located.
Yeah, it's closer to cancer storage building. It's in between the Wessup and the CSB, close to the CSB. And once all the VCCs are in place, basically it'll be through the CSB operational group will basically be the ones monitoring the CSA.
Okay.
Even though they're two separate facilities, they kind of be operated by one group.
Will it be considered an interim storage area like some of the other things by CSB, or?
Oh, what's that?
Will it be considered an interim storage area, an ISA?
Yeah, so something similar to that, yeah.
Anyone else?
If we've worked our way through the queue, the most important question, when do you think it'd be a good time to come back and talk to us again?
Well, maybe when we start loading.
Okay.
So I'll
So,
have video of them actually moving the capsules around.
okay, so, this calendar year, but next fiscal year, is that?
Yeah, I would probably say in the fall.
Bob again?
How is funding looking for this? I mean, you're pretty far along on this.
Yeah.
Does it look like this is one of the high priorities for actually getting the funding?
Yeah, I think this is the third priority, Hanford priority for third. Yeah, so, yeah, we haven't had any issues, so far, with, being able to get the funding needed to support this effort, so. I know, it's pretty high priority for Vance, that, for our manager to get this thing out and reduce the risk of Hanford footprint, so, yeah.
When you mentioned, massive, where they're doing the mock-up stuff, I had flashbacks, because I used to work at FFTF. And we worked in massive, where we did a lot of the, decon work in there. And so, yeah, it's just, I think it's really good that they're able to still use that facility, for the mock-ups. I know the 324 building also did some mock-up stuff in there as well, so. But yeah, slight little flashback there. At the FFTF.
No, it's been very, very beneficial for the project to have the mock-up. Like I said, we learned a lot during the testing of the transfer equipment. And based on those lessons, we were able to adapt and modify the production equipment that was installed at Westfield. And like I said, just getting the operators, do training, get proficient at using the manipulators. I remember when they first started, went out there, and it took them 15 minutes to get one capsule loaded into the UCS, and now you go out there and it's, takes them a minute or two. They're pretty quick.
Well, we love having you a committee. I think though, this is a big enough achievement once these things start getting loaded that we might want to go to full board instead of just committee. Because that's a major achievement. It's been a long time coming. So thanks and keep up the good work.
Thanks.
That's back to you, Jeff. We need an open forum.
Okay, so, this is the time of the meeting when, I try to stop talking and let everybody else who has ideas, shout, not shout, talk. So if you're online and you want to talk about anything that is on your mind, preferably Hanford related, you can do that. If you're in the room and you've got a soapbox that you want to stand on, or an anecdote you want to talk about, making season Australian capsules back when they were made, thanks. Maybe something about those cesium strontium capsules that were made from this liquid that fell through the hole in the floor of a building you work in. It's all connected, right? Or something altogether different. So anyone for open forum.
Feel the energy in the room.
Right.
Oh, man.
I thought it was interesting that on the video, they're gonna bring them into the hot cell and then they're gonna inspect them, and it talked about serial numbers and all that, and so in my mind, my mind is racing like, well, some of those are actually degraded and, corroded and that kind of stuff, so I wonder how,
Put your good
if the
glasses on.
serial
Right.
numbers are still gonna be there, right? Yeah.
I have nightmares about corrosions. I wear glasses now, when I read,
Right.
so it's like, how are you gonna, you can't like put your glasses on and get closer to the thing, because that's not,
Right,
no.
especially looking through that leaded glass,
They do have a camera technology that can sort of scan and, yeah.
Yeah.
One thing that I was thinking about is, I'm a Hanford nerd and I like thinking about this type of thing. When the Plutonium finishing plant was being demolished, and also when the Purex tunnels were being filled, we would get like weekly PDFs of progress. And it seems like this might be a project, the WESIP, you know, once we start operations of getting it into CAS, that would be a really great resource that DOE could put out and say, here's your weekly update of where the WESIP capsules are. That type of thing, and more fact sheets and videos that make it easy to understand, like, and I'm assuming there's some production costs because they're fairly well done, but more of that, making the complex concepts approachable and understandable really could go a long way.
No, I'd watch it again now. You've got it. It's only 5 minutes.
It's on YouTube,
Pull it up on YouTube.
right?
Oh, it is.
Yeah, it's on YouTube.
So Tom, what you said kind of goes along with discussions we had last year about risk communications.
Right, that's
You
perfect.
know, it's, the public has to read this stuff, but they might watch a 4-minute video.
Well, and communicating progress of reducing risk is important too.
Yeah. There's some little good news or about Hanford, that something like that would be good.
Yeah. This is to me, this is the last big scary thing that would potentially affect the offsite area. There's lots of stuff that's scary on site that the workforce has to deal with safely, and that's just the way it is.
So Jen, DOE doesn't send you videos, right? It's all the contractors.
We do, yes, but usually hand in hand with our contractors.
Yeah.
So. Yeah, always a good way to story tell.
Yeah, you gotta tell the story, and especially when there's no requirement to publish a document. But there's work being done, and there's a lot of work being done, and it's being done safely and it's being done effectively. For the most part, you know, there's a lot that doesn't make it off-site, information-wise. We don't want other things to make it off-site. Information should be getting off-site that there's progress being made. And, you know, these historic buildings with a lot of risks associated with them, and asbestos and beryllium, all this stuff is being mitigated, and we never hear about it because there hasn't been a milestone big enough to publish a report. So just my soapbox is, you know, tell the good stories as well as the bad, and we can cheerlead.
Well, we sort of alluded to that in the 2027 work priority plan, is at the start of the year, we suggested that DOE publish what are the goals for the year, and especially operational, you know, how many of this did we do, how many of that did we do? At the end of the year, tell us what they accomplished.
Mhm.
And I think that would fit in with some narrative to exactly what you're saying.
Right, and it all ties into the work planning process and the agencies getting together and, you know, really getting a good picture of what we're gonna be looking at. I'm always trying to find topics that are 3 to 4 years out, because that's what's timely and appropriate for our advice. Because once you're closing to 3 years for a project, everything's already been decided, right? The budget's already been requested.
Well, especially once you're in operations mode, you're doing the same thing day in and day out, and the people who are doing it becomes routine. And they sort of forget that while it's routine for them and what's happening, it's not at all necessarily routine for people outside who aren't involved in that. So I think telling that story, here's how operations are progressing, would be really good
Yeah, I remember when,
on a regular basis.
when they were putting out the Purex, it was Purex 2 tunnel, they put out a PDF every week of the progress that it made, and it showed the ground level in the tunnel. And I put them all together in a flip book, so you could watch it. I told you I'll be geek. Speaking of making little movies, right?
Yeah, right.
Because it's stop motion.
Yeah.
You know, that might be a good advice topic, what we were just talking about.
I forgot what we were talking about. That would be for code, though. Probably.
The, putting out regular updates on.
Oh, right, on West.
Operationally, the progress in operations, we've done this, so someone can plot, you know, yeah, this, we're getting done.
Right. I wonder if it would make sense. I mean, WESIP is a nice package because we know that this is the number of capsules. It might be more challenging for DF law or something where, but you could show, number of logs made, I guess.
Well, they'd like to produce three canisters a day when they're fully operational. So that'd be nice to see. This month we actually produced 2.95. Next month we're gonna produce 3.13, something like that,
Yeah,
average.
so who wants to volunteer to bring that idea to the council?
You started.
And really what we're asking though for, excuse me, is, DOE to be more, upfront with the actual, schedule and deliverables and more free with that information and what their plan is and that sort of thing. And we don't have it.
Right.
So.
Yeah, I guess that's sort of on my list of topics for the work plan is, you have all these, action memorandums to take down ancillary structures and all these different canyons and get these canyons ready for eventual disposition. But there's no like published schedule of which one's going first and how long each one's anticipated to take. Is it decades? Is it years? Is it months? And having that information at hand as a have would be helpful so we can produce timely advice. Because if we're producing advice on reports that are already written and projects that are completed, it's not helpful. Any other open forum topics, discussions?
See anyone in the room? That's anyone online, volunteering, nice.
Okay. You want to move on to June and what's on the docket for potential talks?
So right now I have confirmed, I would say tentatively confirmed the Ernest briefing, which would be joint with the LIDS committee. I'm still pulling the strings on the risk communication and strategies, which I think has been talked about a lot today. So maybe that could be timely for June, but still don't have that confirmed. And then those are the bullets that I had listed at this point. I have reached out to the SME, so I am just kind of waiting to hear back from them on topics. Is there anything I missed, Josh? I know I've been in talks with you a lot this week.
I don't think I had anything else from DOE. Something I noted from the last meeting, with EPA. Unfortunately, Roberto's gone. They suggest there may be new PFAS information available around the June timeframe. And there was discussion of a potential CERCLA 5-year review primer or findings. I'm not sure where we are in that process.
Yeah.
I talked to him yesterday about PFAS and he said at this time, there's nothing new to update. So I'm not sure that would be probably not timely for June unless something between now and then changes.
Maybe the 5-year review could fit in. The other thing that's on my radar is June's a little early, but we heard early summer or late summer, sometime this summer for the 324 proposed plan.
Okay, yes.
And we'll be having potentially advice coming forward for that. So I'm not sure how the timing will work with getting a briefing. And then I think we talked about maybe the full board for the briefing.
Yeah, so it depends on timing. That is one that I'm in discussion with Ben Vanna on, and it sounds like June will be really timely. But the idea is that it would maybe be a committee of the whole, because it would be obviously of interest to everybody. So at this point, it sounds like June would be good for that.
Okay.
How we'll work that out, I don't know, because we've got subcommittees and a leadership workshop. But June would be great for 324.
And then if we could incorporate IM team work session into that committee of the whole, if we did that before committee week.
Yeah.
It's very tricky. But because we have to have this committee approve the advice before it goes to the full board for consideration.
Right.
So just logistically, we'll have to figure it out.
It's a tough one. I will say comment period wise, I think what's required, and I think at this time, that's what's on my radar is a 30-day comment period, so that. I guess not in your benefit, right?
Which we've often heard that had advice taken outside the comment periods is still valid and it's still responded to. But if we wanted to be in the formal records
Sure.
in the comment period, yeah. So that's my radar for June is 324 and yeah, the circle 5-year review. Erdic would be awesome. And
I think we're is a go.
that's the challenging thing, sorry,
Go ahead.
The risk communication is joint with COE. And the Erdic is joint with LIDS, so it might be hard to do both of those in the same
Yeah.
meeting.
COE's also starting to look a little packed, I think.
Yeah.
Right.
So maybe we can push that one.
And another note, you also mentioned cross-site transfer as a joint between
It's a joint,
Lids and
yeah.
Twist, so we're really gonna need to be doing some realism sorting,
Yeah.
or be holding 4 committees each day, 2 days in a row.
And they're all joint, right?
Right.
Okay,
We took committee of the whole week,
yeah,
same committee week.
I guess it's a good problem to have.
Right.
yeah, I agree.
Okay, so June will be fun. We'll also have, another look at the work plan. Like I said, my homework is to go back and see what we requested in the past that might still be valid, and I'll shoot those out. I think I have all of our requests going back to 2020 or 2019, so we can see what's still sticking around. And then we have leadership elections, so your homework is to throw your hat in the ring if you're interested. It'll be a fun summer.
Busy.
Did we manage to shave off an hour?
Yeah, it's about 2 hours before the formal meeting. I mentioned
Way too early for dinner, but I guess, anybody have anything else to talk about?
Public meeting over there tonight.
5:30, 5:30 next door, come back and talk about budgets for 27. Or cleanup priorities, not budgets. Okay. Thanks, everybody. Have a great day.
All right.
Thank you.
Yeah, it's just no share your hand up.
Sorry, we're not adjourned yet. We didn't say the word.
Hello. I just wanted to, I think it's probably obvious, but for Jen, since we're planning committee of the wholes that aren't on the calendar yet, to just let us know, as soon as possible, those dates, especially for those of us that are traveling. So we can make sure we make the time on our calendars and adjust accordingly. That's all I wanted to say. Thank you for a good meeting, everyone.
Yeah, thank you. And maybe we can just start socializing a date. Just at this point, I don't have 324 dates and when that's going to be timely, but we look at the calendar and maybe put some and roll a couple dates in. I don't know.
My note on that would be, I believe the agenda deadline would be towards the end of April, so we may want to consider either a planning meeting around the end of this month or address that in the next ESC call.
Okay.
Okay, now we're adjourned.
Okay. Thank you very much.